Okay, let's read the question. What gravitational force would a 100-kilogram football player experience from the Earth? Now, first, just as a reminder, in a question like this, when they give us 100 kilogram, 100 kilogram has the units of kilograms, which is the units of a mass. So the 100 kilograms refers to the mass of the football player in this case. So we know the mass is 100 kilograms. And we know we are being asked to find the gravitational force at the surface of the Earth. So that's easy. We just use this. Fg is going to be equal to 100 kilograms times minus 10 meters per second squared. The minus is to represent the direction that we have here. It's in the downward direction, so it should be minus. And Fg comes out to be minus 1,000 newtons. The minus again tells us of the direction, tells us that F sub g is downwards. Okay? Now, we'll try to probe this a little more. The question now is asking us, what would the football player experience from an equal mass player standing 1 meter away from him? Okay? So what we have here, two football players a meter away from each other, and each one of them having a mass of 100 kilograms. What force would they exert on each other? Now, to do that, we are going to use this expression. We don't have the Earth involved anymore. We are talking of any two masses. Okay, so when we do that, so let's use the formula. It's G, which is given to us here, 6.67 10 to the minus 11. I'm going to do an approximate calculation here, just to give us a bulk figure. I'm going to approximate that to 7 10 to the minus 11 Newton meter squared per kilogram squared. Or what the heck, let me calculate it precisely. A thought crossed my mind that some of you might want me to calculate it precisely. So that's why I'm going to do it right now. 6.710 to the minus 11 Newton meter squared per kilogram squared. Now times the mass of the first football player, which is 100 kilograms, times the mass of the other football player, which is another 100 kilograms, over 1 meter squared. Now, okay, let's calculate these. 100 times 100 is 10,000. 1 squared is 1. So 10,000 over 1, so it's 10,000. So this is 6.67 10 to the minus 11 Newton meter squared over kilogram squared times 10,000 kilogram squared over 1 meter squared. You notice here the meter squared is going to cancel with this one, the kilogram squared is going to cancel with this one, and we are left with newtons. And we have 6.67 10 to the minus 11 times 10,000 over 1. So that comes out to be 6.67 10 to the minus 11 plus 4. That's what we have here. So 10 to the minus 7 newtons. That's our F. 10 to the minus 7 newtons is very tiny. It's about a millionth of a newton. Compare it to this, where we are talking of 1,000 newtons. A millionth of and 1,000. So the force that the Earth exerts on the football player is 1 billion times as large as the force that the other football player exerts on him. Okay? Now, a billion, that's because this is 1,000 and the other one is a million. So 1,000 millions is a billion. Okay. So this force is very tiny. Since it's about a billionth the force that the Earth is going to exert on him, actually, we are not going to feel the effect of that force. It's not going to affect most of what we do. It's a very tiny force.